If you've never been to one of these before, then this is the London Java community event. We run these on a regular basis. If you are a Java developer or just curious about Java, then we have a website, a mailing list, and obviously a meetup. If you want to know more about Java, then reach out to us and we'll help you. We run events on a regular basis, and we're planning to run the summer LJC conference. Is currently planned for the 11th of July. So for those on the call, don't tell anybody else, but that's what we're looking for. Cool. Listen, I will get out of the way and I will hand over to Lukman to do his thing.
Retrieval Augmented Generation with Jakarta EE. First of all, a quick primer on Gen AI. As we are all aware, you really have to be aware. If you're not aware, we need to have a few discussions afterwards. Everything is AI now. Everybody is talking about AI. And the large chunk of the discussion is focused around generative AI. And so first of all, to situate to contextualize our discussion, what is generative AI? We are pretty much AI systems, artificial intelligence systems that create new content. They are really good at creating lifelike, human-like text and all of that. So they create new content based on large language models. And you can think of LLMs. If you don't know what an LLM is, if this is your first time, you can think of LLMs as very, very huge statistical machines that use statistics to predict the most probable next word to give to you in a given sentence. So they are large statistical machines that are trained on vast data sets, and through that, they are able to generate human-like text or human-like content just based on what they've learned from the massive amount of data they have. And speaking about generating content, one of the strong points of Gen AI is using it to augment your own documentation. And to do that, you can use one aspect of Gen AI orchestration called RAG, Retrieval Augmented Generation. Pretty much combines LLMs, the power of LLMs to learn from data with your existing enterprise data, especially in situations where you don't want to put your data out there to anything. You can bring the LLM home and then use it to help augment your data to improve accuracy through context retrieval and help reduce hallucinations. And the goal of that is to pretty much give your users a good experience. Most of the time now, if you go to all these huge sites, if you go to Azure, for instance, there's all these pop-ups there asking you to speak to the AI and all of that. They train it on large data sets, and then through these data sets, the model is able to do all of these things. So how is the application flow that we're going to look at is like? Now, I titled this Zero Ops because personally, I'm not a big fan of managing infrastructure. Of course, I can manage infrastructure, but I really find that time consuming and very draining. So I prefer to use ready-to-use services to manage infrastructure that are not in the purview of my primary expertise. My primary expertise in delivering business value to customers. So I like to do specifically that. However, there are things that we all can do away with in development. We need to store data in some kind of database. We need to host files somewhere and all of that. Of course, you can orchestrate all these things in your own data center if you have the in-house resources. But if you don't have the in-house resources, or if you really want to put those resources to a different use, then you might want to consider external services. So in this example, we're going to store our data in the Neon database. If you don't know, if you are new to Neon, Neon is pretty much Postgres, from your perspective, serverless service that gives you a ready-to-use Postgres database without lifting a finger. So you just go to Neon and spin up a Postgres database, and then you are good to go. And their databases come with PG Vector activated already. So it's ready for storing embeddings. And then we are going to use Azure Storage Container to store our files. Now, in the RAG pipeline, you're going to have your LLM sitting down, probably hosted in your own data center, or you can use OpenAI service. And then you're going to have some kind of data you want to embed and use to augment responses from the LLM. So we need that data, and where we want to store that data will be the Azure Storage Container. And then we're going to use LangChain for orchestrating all these things in code. So too much talk, let's jump into the code. This is a pretty simple, very underwhelming Jakarta EE code. The root point entry to this code. Steve, anytime there's a question, just let me know, and then I can answer it right in the discussion. Yeah.
Yep.
Okay. So the root point entry here we can start from is the embedding service. It's an interface that different embedding services can implement. We have just one implementation in this code, and that is the Postgres embedding service. So we have a Postgres embedding service here that implements the embedding service, and then all it does is embed documents. Now, how does the embedding flow look like? What is happening in this embedding service here is that we first start off by loading blob objects, the keys to blob objects. Now, if you are not familiar with blob object, it's just a fancy name for files, really. Blob object is, the blob objects are loaded from our Azure container, our Azure storage container, and then we iterate over it one after the other. And then if there is any, we iterate over it and then embed it. Now we can simply walk through here. The document loader here is an Azure document embedding document loader implementation. This is also an interface. So you can have different implementations. You can have one to AWS Blob Storage or S3. You can have one to Google's Blob Storage service. What we have here is to Azure here. And this is how the implementation looks like. Now, if you've not used Jakarta EE before, or it's new to you, you would see a few things that you may not be familiar with. So let's have a quick walk through them here. We are injecting necessary component here to be able to configure the blob storage client. Now, we are externalizing the configuration because there is absolutely no reason why you should ship API keys and any other sensitive information with your code. So these are externalized and are read as part of the application's configuration. And what the API we are using here is the microprofile config API. So we are injecting these properties into this class here. You can call it a controller, you can call it anything. It's just a plain old Java object, or in Jakarta EE parlance, it's a CDI component. So we are injecting these properties into the CDI component here, and then we are using that to instantiate a blob service client here. Now, LangChain, this is where we transition to LangChain. LangChain has a number of abstractions over the popular document stores. What we are using here is the Azure Blob Storage document loader from LangChain. So all we are doing is just instantiating the blob client and then passing it to the Azure Blob Storage document loader here. You can just download the sources here and then passing this here. So we instantiate a document loader. Now, this is an abstraction that will go in and then load documents for you. Now, I'm using the word document here a bit freely in the context of LangChain and AI and RAG. Document is a special word here that represents an unstructured piece of text that usually corresponds to the content of a file. So it's a document and it can have metadata and other things associated with it. So LangChain gives us this abstraction over the Azure storage, container storage that we can use to load documents. So we load document here, and then in the documents that we load here, in our Postgres, here, in our Postgres embed service here, we load the document. What we do first is load the keys to the document. And then if there is any, we start the interesting part. We load the document, and then we split the document. The splitting here is very important because you can have a document, a PDF file that is tremendously large. You can have a file that is thousands of pages long. Now, you don't want to take this huge file and then embed all of it. You want to take that file and then split it into meaningful chunks. Then you can embed it. But what exactly is embedding? Embedding is pretty much taking text that you and I can read and understand, and then translating that text into its numerical representation. Now, if you remember, in the beginning, I said the LLMs are huge statistical machines that use data to predict the next word. Most of the time, this data is in numerical form. That's what they understand. You and I read English. The LLMs most of the time just understand numbers. So we embed those documents into their numerical representation. Here, we split large documents into text segments and then embed it. Now, we use an embedding model. This is a special model that takes text and then gives us the numerical representation of those texts. So here, we would have our numerical representation, which is called an embedding, and then we finally store that embedding into a database here. And that is pretty much all the workflow is about. So go to Azure Blob Storage, scan a given directory for files. If there is any file, read it, go to the embedding model, transform that file into the numerical representation, and then that is pretty much it. Take it and drop it in the database. And that is all there is. Now, embedding the document is one part of the Retrieval Augmented Generation process. The other part is using that embedded information to aid in answering questions by the LLM. So that is done through the concept of content retrievers. This is also something that LangChain provides for us out of the box. A content retriever is pretty much a construct from LangChain that takes a request from a user and then goes to the embedded database and looks for the closest match to that particular query by the user. Fetches that contextual data in addition to the user's query and sends this information to the large language model to help it answer the query within the context of the embedded data. And so this content retriever is pretty much sort of a middle guy, a middleman that stands there, takes input, the user input, goes to the database, the vector database, looks for the closest match. Remember, our information will be transformed into the numerical representation. So our information is now in its numerical form. The content retriever goes, and then that is one of the jobs of the vector databases, gets the closest match to the query that we have, gets that particular context, asks it, and then sends it to the LLM to help it answer the question in a meaningful, contextual manner. And that is pretty much all there is. Now, the interesting thing here is that nearly everything here is just plain old Java. If you've never done Jakarta EE before, you've never done Java EE before, or you fled in the days of J2EE and never looked back, a lot has changed in that field. And this is nearly identical to what you would do in Spring, because everything here is a plain old Java object. There is nothing from the framework that we are extending or implementing here. we are defining a data source here. And a data source is pretty much a way to talk to the database. And what we are doing, even in the data source definition, is actually using the microprofile properties to load the necessary database credentials here. Now, these database credentials are directly from the Neon database. Remember, Neon is our serverless database that we are going to use to embed our information. So these configuration values here are also from the Neon database. And then we are just injecting these properties here into the data source definition here. And pretty much that is it. There's nothing else we are doing here. And this will spawn a database connection for us. And that is what we are injecting via the JNDI name here into this data source. Now, this data source here is used by LangChain's PG Vector embedding store to instantiate the embedding store here. And pretty much that is it. There is nothing fancy about Jakarta EE in here. It's LangChain doing all the heavy lifting with bits and pieces from the Jakarta EE platform to sort of glue together the various parts. So this particular vector database here, this particular Postgres embedding service, implementing the embedding service here is injected in other places just to do its job well. So if we come here, we are injecting this Postgres embedding service here and using it to get the content retriever. And this at inject here is from the Jakarta EE CDI or Jakarta CDI specification to pretty much inject things into components into each other in Jakarta EE. And you can think of this at inject as not so different from Spring's dependency injection at AutoWired and all of the other construct that Spring has to inject things. It's pretty much similar. So we are just writing plain old Java application with bits and pieces from Jakarta EE, like this application scoped here, which makes this class a singleton across the application. And then there's a post construct here that will call this method. This is a lifecycle method that will be called automatically when this class is instantiated, because we want to do some kind of initialization here. So this class is called and then instantiated. And then that is it. There is nothing fancy in here. So enough of the talking. Now to run this, there are a few things you need to do. Of course, the code is available on GitHub. I'll send you the link to peruse it, but you would need to provide certain properties. As I said, if we go back to the Postgres service here, we have these properties here that you would need to provide, for instance, the database URL, username, and then the database password. And then also, if we come to the OpenAI factory here, you would need to provide your OpenAPI key here. There are some properties, some harmless properties that have values bundled with the application. For instance, the GPT model we are using is the GPT-4 Omni. And then for the embedding model, we are using, should be embedding model. For the embedding model, we are using the GPT 3.5 Turbo embedding model here. So these are harmless things that we can bundle as part of the application. However, for the more serious properties, the restricted properties, like the username and the password and all of those should be in the environment the application is running in. Now, locally here, I am running this via Docker. And this particular Docker Compose here is pulling these properties from my system. I've set these in my system as part of my system properties, and these are being pulled directly here and set for the application. So this is my OpenAPI key, my SaaS token. These are the Azure storage key and URL that I'll use to authenticate to the Azure storage container. And then there is my database user and password here set. And then there is my Payara container, Payara server container that I'm using to deploy the application. So in effect, this is all that I'm doing to get this application up and running. There's also something here for telemetry, but that is not a discussion of this. That is not a focus of this discussion. So to summarize, this particular application here is a dead simple application that is using that is using LangChain4J to orchestrate the Retrieval Augmented Generation in Jakarta EE. Again, there is really nothing major from Jakarta EE itself in here, other than using bits and pieces of it to orchestrate the needed part. There are things like injecting the config property and then setting the scope of the bin, and then also this annotation here. Max is a CDI construct here. It's a CDI construct here that is used to mark methods in this class as transactional, because we'll be carrying out database functions here. So we want to run those in a transaction, but pretty much nothing Jakarta EE specific. And as you can see, I'm using Docker here to run the application. And this here should work out of the box for you. And the image I'm using here is the Payara server image. This is the latest release of the Payara server community here to run the application. So let me stop everything. Clear. And then let's do Docker compose. Down. Move everything. Any questions so far, Steve?
No, it's clean.
Okay. Okay, so Docker is down. Let's restart. It's a clean slate and go. Okay, so this should start. Now, if you notice here, there's something about copying something to deployment. What I'm doing is that I have a folder mounted here. That is a folder here that is mounted to the deployment folder of the server. And then this folder here, the server scans it at runtime for deployment artifacts. So if there's a WAR file in this container here, in this folder here, the server will deploy that WAR file. And that's exactly what we are doing. So this folder here, this deployment folder here, is mounted to that particular folder in the server. So let's check what is going on here. So the application is deploying here. And then you can see it has connected to the Neon database. Now I can bring my Neon console here while this deploys. This is my Neon console here. There is nothing in the database here. It's a very fancy looking, but very underwhelming scene at the moment. Here, there's nothing in the database. The table is empty here. There's nothing in here. So let me take this off here. Now, while this deploys, there is something I just want us to briefly look at in case you are wondering what is going on in the code. Here, there is a context initialize observer here. What is going on is that we have a listener here that is listening for a specific scope. Now, in Jakarta CDI, we have the concept of scopes. And you can think of scopes as pretty much a scope that an application or a component can live in. And then we are listening for the application scope here. And if the server starts up and then this event is fired, we want to start this. We want to initialize these things in this method here. Now, why we are using this listener construct here is that we want this class here to automatically start scanning our Azure folder, Azure container, blob storage container at application startup. We don't want to trigger anything. We don't want to have to manually trigger the scan. We want it to automatically start scanning once the application spins up or once the application starts up. And that is why we are listening for the application scoped context event and then calling the method to initialize it. And here I have a timer. This is a very simple timer from the java.util package here. And I'm saying every initially delay for 0 minutes. And then after that, every 30 seconds, run this method, this embed new docs method here. And so this method will be called every 30 seconds. Now you can also alter this interval through these properties here. Now we set this through the microprofile config. And again, this can be externalized to whatever environment your application is running in. At the moment, it's development. So it's pretty much every 30 seconds run. But in production, you absolutely want to be careful. So we are saying every 30 seconds, just run this method or call this method, and this method will go to Azure Blob Storage, look for documents, embed those documents, store the embeddings in the database, and then move the embedded files to an embedded files directory in the blob storage. And that is pretty much all there is with this application. So this has deployed for us. And as you can see, there are logs here. Let me just clear this so we can see it well. So I did say 30 seconds. So let's wait and see. This is automatically running. So this method is going to be called intermittently in this timer here. Of course, there are other ways you can set this. You can use cron jobs and all of that. I just find using the whatever comes with the platform always as the first option and the cleaner way and the simpler way. So I just use the timer from the java.util package. So you can see the method has been called here. This is starting embedding. Here, no documents to embed like that. So the method has been called no documents to embed. So now the moment of truth. Let me upload a file to my blob storage account here. So this is my Azure Blob Storage. Let me bring this on screen. Delete. Bring this window here. This is my Azure Blob Storage account. I'm going to upload a document in here, and then let's see what happens. Hopefully it works well. I don't get plagued by demo gremlins that always stand on your shoulder and then make things never work when you are demoing. So let me upload this file here. Jakarta SQL. Okay. Okay, so I'm uploading a file. We can put a breakpoint somewhere in here just to see. Load, no, not load documents. List objects. Yeah. Yes. So we can put a breakpoint in here. Let me attach a debugger to this guy. Attach process. Here. Let's see. Okay. So I'm attaching a debugger. Now in the next run, this should work for us. I did make some small changes to my storage account just before going live because Azure. But yeah, so let's wait for those to hit and then we see. Okay, so we hit here. Now the storage container is EclipseCon here. As you can see, this is the storage container. EclipseCon is referring to these containers here. So list objects by hierarchy here and see what is going on. Download sources here. Let's start step over, step over, step over, step over. Okay, so it's not seeing. There are no objects available, so it's not seeing. Now, what is this here? Let's read the Java doc. Run, remove this. Okay, so returns a reactive publisher, blah, blah, blah. And then here is prefix true. Okay, good. Here, get content. So list by hierarchy here. What I am trying to do is to list only files because within the directory, within the storage container, you could also have directories in there. But what I want to do is to list only files in there. somehow Azure seems to have changed this API call here over the last few weeks. Okay, good. So we pass in the directory, you can just say Eclipse. What is the name here? No, embedded file. Well, we can just pass this in here directly, like this. Say Eclipse, con, and then stream. Okay, so let's redeploy this. Yeah. Any questions in the chat, Steve?
No, sorry. You're
Okay.
stunning us all.
Hopefully, the attendees are not asleep, rather. Okay, so our deployment is running. Okay, this is done. It's an expected exception. Yeah. And so let me put another output point here. Okay, so this is deployed now. Okay, yeah, the point. See, we step through and see. Nice, well done, Microsoft. Okay. Yes, so we are here. Step over, step over, step over, step over, step over. Okay, this is strange. Why is the client not returning the file? Of course. Here. No error. Get clients. List blobs by hierarchy. Yes. And what is the Java doc here? This is what's used in Eclipse conf. Listing container. Okay. So I just updated to the latest and it looks like they changed this just before. Okay. Remove this. And let's see. That's for each block. Yes. Block that is prefix will return the result. Okay. This. And then let's try give this a shot. Okay. Or better still, let me change the version because I just updated this afternoon. So let me change or downgrade this version. I'm not so sure what changed the API. Sure. Quite yet. Okay, let's give this a shot again and see. I am not so sure what changed in the client, because we needed to just pass a directory, a root, a forward slash, and then it should give us all the files in the container, the blob storage. I am not so sure what changed with this version of the client connector I am using. Yeah, okay, let's give this a shot again. And this time around, probably I got the spelling wrong. Or better still, you can just see list blobs like this, and then not pass anything. List blobs. Okay, so let's give this a shot. Yes. Okay. Okay, so let's give this a shot again. And then wait for it to scan. Okay, let's wait. So now it found our file here. Our file has been found, and this is being embedded. So this is the content of the file. This is the Jakarta NoSQL specification that is being embedded. And as you can see, there's the numerical representation being printed out. So this is the response from the embedding model of the document. I can open the document here for us to have a quick look at it. Here, Jakarta NoSQL. So as you can see, it's a lot of numbers, and this can get tremendously large because the embeddings get very large. The numerical representations of the documents get very, very large. But this is the document currently being embedded. This is the Jakarta NoSQL document being embedded. There are 40 pages in this document. So this is being embedded here. Now we can go to the database and see if there is something in the database table yet. So you can see the database table now has some data, and this is the numerical representation of the file being embedded here. Now, again, just to warn you, this can get tremendously large. So if you want to play with this, make sure you have enough space in the database you are using. Otherwise, you would end up running out of space, especially if you use very large files here. So this is being embedded, and depending on the size of the file, this could take some time to do. As you can see, it's just printing large numbers here. It's just number, and just number after number after number in the console here. And depending on the size of the file, this could go on for a while. And that is why I stated in the earlier discussion about the timing that in a non-trivial application, you want to be a little careful with setting the time to be so short, because you would end up probably using resources that you shouldn't use. Also to note that this document being printed in this bits or segments being printed are from the embeddings, the text embeddings, Postgres. They are from the text embeddings here. So embed, load document. Nope. They are from the text segments here, documents.load documents here. There's implementation here, load documents, is embedding, loading the document, and then splitting the document into the text segment and then embedding. So if you go back to the console here, the logs here, this is coming in chunks. So each text segment gets embedded and then sent to it gets chunked into a text segment and then sent to the LLM model to be embedded into the numerical representation here. So again, depending on the size of the file, this could take some time. Of course, this is a normal developer machine. There's nothing fancy about this, but if you are using your own on servers, that could be fast. This could be a bit faster. But then if you have large numbers of files, this could impact performance. So just keep that at the back of your mind when dealing with this. So as you can see, our database is being populated. Let me refresh, reload this. And this is getting stored in our new database here, right from the code in the IDE that is currently running. So there's a lot of things here. There used to be nothing. Now we have a number of rows. How many, I don't really know. There could be a lot, but this is how the embeddings pretty much look like in the data store. So each particular text segment with its numerical embedding representation. So for this particular section here, this is the numerical representation of it. And so if we have our text embeddings, how exactly do we use this? Now, if we make a query, we can go to the UI of the application, then come to localhost :8080. So you can see there's still the embedding going on. The text segments are being broken down and embedded bit by bit. These are all text segments. So this is from the specification. And then this is the numerical representation. If we come to the application here, come to the bot chart. So this is designed to answer questions pertaining to the organization specifically. Now, if you ask questions outside of the scope, it will tell you no, because we are pretty much telling the LLM exactly how to respond here. Let's move to transition to that. Here, again, all of that is done by LangChain for us. So we have this Payara chart here, and this is pretty much the LangChain abstraction that we are getting out of the box. We create an interface here, and then add in some annotations. We have our system message here, and then we have a number of methods here that we've annotated. So we are using our system message, and then some annotations here to tell the implementation exactly what to do. So this method here, we are using it in this backing bin here. Now, this application is a vanilla Jakarta server faces application. So let me start and just say hi. Hopefully it doesn't crack. So yeah, hi, blah, blah, blah. However, this is a local message. This didn't go to the server because, of course, you can easily predict messages that will generally be asked by users. So somebody would come in and just say hi. So here we are saying there's a message, hello, hi. Don't bother going to the server. Just respond with this message. Now, let's go in and do something much fancier. Tell me. First of all, let me check if this is done, because I am going to ask it to tell me about Jakarta NoSQL. So let's see, let's take it for a spin if it works.
Luke, when you've got 9 minutes.
Okay, great. So let me just do a quick this and then I can wrap up. So ask it about Jakarta NoSQL and then let's see. So this guy here, this request here is now going to, two things are happening here. The LLM, the LangChain library takes my query and then goes to this database here to look for the closest match to my query, and then takes that and sends it to the LLM as part of the context to answer the question. So here, Jakarta NoSQL has emerged as a powerful blah, blah, blah. This integration simplifies development, allowing for blah, 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 blah. So this here is most likely taken as part of the information we are embedding, even though our embedding is not fully done here because the file is large, and depending on the server load, OpenAI sometimes I find throttles my request in bits and pieces here and there, but this is being embedded still. So in a nutshell, this is pretty much how the workflow is. You take the data, you have to decide how you want to handle the files, you have to decide which embedding model you want to use, you have to decide which database you want to use. Is it going to be hosted locally, or it's going to pretty much, you are going to use a hosted service like I'm doing, which is Neon database. In effect, you have to decide all these modalities. But once you do that, you make that decision, it's pretty simple to get the application up and running through Jakarta EE. Now, we've looked at running the application locally. We've explored Neon. It's the serverless database. There's nothing we need to host. It's just works for us. And then we are using OpenAI, of course. And then there is also LangChain4J, which is pretty much the orchestrating library that we are using to talk to the LLMs and then do the embeddings and talk to the vector database and all of that. Now, all these are are running on the Jakarta EE platform using very, very small constructs from that. And then once you are done, you would also need to deploy your application. And in those cases where you don't want to host your own server and things, then you could also deploy to a managed service like we have in Payara. We have the Payara Cloud Jakarta EE serverless service. You can call it serverless, or you can call it a hosted Payara as a service, where we simply host the server for you, and then you just need to bring your application and deploy it. So these are all ways you can orchestrate. Enterprise Retrieval Augmented Generation applications on the Jakarta EE platform. So as you've seen in the code, you don't really need to use a lot of Jakarta EE specific things. All you have to do is to use bits and pieces from it. And then you have a very great library like LangChain doing the work for you. And then also you have external services, really awesome services like Neon database that are going to give you the database as a service without you needing to host your own database, Postgres database, and all of that. Out of the box, it comes with PG Vector available for you. And then also there are serverless services, or there is Payara Cloud like this for deploying your Jakarta EE application. So in this case, this is the same application I am deploying here. So what we are running in the Docker container here is the same thing I am deploying up here to Payara Cloud, and this should deploy the application and then make it available for use. Now, as you can see, the embedding is still running, and this depending on the speed of the embedding model, this could take some time. As you can see, it's still taking some time. It's just 40 pages. So again, you can imagine embedding large data set, you need to really take performance into consideration. Okay, so there is a question from Dimitri. He says, while LLM-based logic might work technically, sometimes the quality of generated content might not be satisfying. How to measure that? The quality of the response is always related to the kind of data that you are using to augment the response. So in this case, we have our own custom data, so which is the, let's say, Payara service documentation or the Jakarta EE specifications. An example is what we uploaded here. Now, this is the contextual data that you will use. You would also want to use system messages to actually restrict the scope of response that the LLM will give. In this case here, we have a long system message here that is setting the scope and context that the LLM is going to, or will be expected to confine itself to. But in the end, everything is a matter of testing, and you measure and then you take corrective action. You measure and then you take corrective action. And again, the problem that you raised is why the concept of retrieval augmented generation is very important, because you can help reduce hallucinations. Even though Microsoft says we shouldn't say hallucination, Microsoft prefers the term fabrications. You can help reduce fabrications because you have your own contextual data that you want the LLM to base its response on. So you are using the LLM more like a customer agent than an LLM. So instead of relying on its own trained data, you are using it as an interface to your own data internally. And that is exactly what we are doing with this example. So we embed our own internal data, and then we use it as an interface to that. But in the end, everything is a matter of testing and then taking corrective measures. You will have problems with LLMs. You will have problems, but once you measure and take corrective action, you can mitigate those as much as possible. And your second question says, which types of problems will we face or may we face, and how to cope with them? You'll face problems of hallucinations or fabrications, and then you want to take corrective action with them. Most of the time, it's just a matter of testing and fine-tuning your system and user messages, and then eventually you will get a sweet spot between them without restricting the LLM too much, and then also not giving it too much leeway to do or respond however it sees fit. So this is our application deployed to our Payara Cloud console. And as you can see, we have the same application here, and whatever is running locally at the moment is exactly what is running in here. And Payara is the third of the trio of our Zero Ops platform. We have Neon Database for managing our database. We have Azure Blob Storage for our binary files. And then we have Payara Cloud here that is taking our Jakarta EE application and deploying it for us, complete with the URL and everything out of the box. So in this particular example here, I'm not hosting anything. I'm just using all these external services to orchestrate my application. Steve?
Yeah, very good. Perfect timing. Thank you so much. I really appreciate your grace under pressure, as you had a technical challenge that many of us would have balked at. So thank you for that. Where do you want to send people who are interested in following up?
Yes, if you are interested in following up, you can hit me up on LinkedIn. The code is also available on GitHub, and then you can also sign up to Payara Cloud. Let me just share the code link here. You can also sign up. Let me stop this first. Stop this, because I'm running off memory. You can also sign up for a free trial of Payara Cloud to deploy application. Neon Serverless also has a generous free tier that you can use to get started. So and then you can get started. So go to Neon Tech here. I'll put the link. this.
Are you presenting from the same machine that you're running this stuff on?
Yes, and so you can imagine, yeah.
Yes, yes. Your audio keeps breaking, but I'm not sure if it may just be you're stressing your machine a little bit too much.
Yeah. So check out Payara Cloud. Yeah, for your Jakarta EE free trial deployments, and then also check out.
Yeah, cool. Well, thank you very much. Folks, there are the links. If you want any more, then you can always just come to the JC Slack and I'll ask there, or just reach out to Lukman as he said on LinkedIn. Cool. Well, thank you very much, Lukman. I think we're done, and thank you everybody for attending and listening to an awesome presentation and an awesome recovery. I shall hold that as a high bar for other people. Bye, everybody.
Okay, thank you. Thank you, everybody, for attending. Thank you.